This is for ECET 105 with DeVry University. We are demonstrating part 1 of the lab for week 7 during the fall semester of 2015. In this lab, we were asked to demonstrate the functions of a D-type and a JK-type flip-flop using a 74LS74 IC and a 74LS112 IC. The circuit that you're currently seeing is a little bit different from how the lab asked us to set up. We were asked to set the lab up with one circuit at a time, but for the sake of the video we've set up both circuits on the same breadboard, sharing a clock so that we can see both happen at the same time. Take note that the function generator on the left is connected to the yellow probe for our oscilloscope, and that the outputs for Q and Q naught on the 74LS112, which is the IC to the right, are connected to the blue and pink probes for the oscilloscope. We're going to take a look at that here in just a minute so that we can confirm that the clock that is being sent into the circuit is having the effect that we are expecting to see on the flip-flops, and that everything is acting appropriately. At the moment, we're receiving about a 1 Hertz input from the clock going into the circuit. The 74LS74 IC is to the left. The LEDs that are directly above it, the green that is currently lit and the red that is not lit right next to it, represent Q and Q naught respectively. To the right, the 74LS112 IC has 2 LEDs to its right. The LED to the left is representative of Q, and the LED to the right is representative of Q naught. The switch control that we're using for the inputs for the 74LS74D input is TTL switch number 7 on the board that we're looking at. That would be here. We're going to use that to give our high or low signal to the D input, and then our high or low signal that's going to be going to the J and the K flip-flops are the toggle switches down at the bottom that are currently labeled J and K. The J and K switches are currently set to high. When we look at our truth table for how the JK flip-flop is supposed to work, whenever J and K are set to high and our preset and clear are set to high, we should receive a toggling output, which is what we're seeing with the LEDs at the moment, that are constantly flipping back and forth between one on and the other off, and vice versa. The dip switches in the center are currently controlling the preset and the clear for both of the flip-flops. The 2 switches to the left control the 74, the 2 switches to the right control the 112. The switch to the left of each set controls the clear signal. The switch to the right of each set controls the preset. We're going to take a walk through all of those functions here in just a moment, but right now we're going to take a look at what the output coming from the clock and the output from the 112 IC looks like on the oscilloscope. What we're looking for at the moment is that we currently have the J and the K set to high, so we should have a toggling state being demonstrated on the oscilloscope. We're looking to see the 1 Hertz signal, which is the yellow. And we can see that we're getting about 500 milliseconds per division, and it takes 2 divisions per cycle for our clock, which is the yellow at the top, and then Q and Q naught, which are blue and pink respectively, are showing toggling appropriately on the negative edge as is expected. Item of note for the 112 IC is that this JK flip-flop responds to a falling edge, not a leading edge. So we see that the changes in this flip-flop happen during the falling edge of the clock, which is what we are expecting. we're going to walk through the truth table for the 74, the D series flip-flop. Go through the functions that are expected there. We're going to remove the probe so that we can kind of see some of the other items in place without having too much complication. So we're working with the 74 D-type flip-flop, and again the D input for that is being controlled with TTL7. If we take a look at the truth table, the first things that we are going to look at is what happens when the preset and the clear functions are set to high. This would be the normal state for the flip-flop and ensures the fact that the D input and the clock input have their respective effects. It's important to note that the current state of the dip switches are that when the switch is flipped down, that it is sending a high signal to the clear or preset inputs, and that the switch being flipped up means that a low is being sent to those inputs. Currently we have a high being sent to those inputs, which is normal state of operation. So if we take a look at the three different outcomes that we could have with high inputs on both preset and clear, the first that we'll look at is what happens when we have a leading edge on the clock and a high for the D input. This says that Q1 should have a high output and that Q0 should have a low output. It's important to note that the way that the LEDs are connected for both ICs are that the negative edge is connected to the IC and the positive edge is constantly connected to positive voltage. So anytime that a low is present on one of the pins, the LED would be turned on. Anytime that a high is present on one of the pins, the LED would be turned off. Currently we see that with a low on the D input, we are receiving a low on Q from the flip-flop. If we change this, we should match what we have in our truth table. We saw the LED came on, there was a slight delay there, waiting for the clock leading edge to change. If we go back to the low state, we should come back to having the green LED on. We did, with the same type of delay waiting on the leading edge. Next item of note is that with the clock input edge, if it stays constantly low, then we will have no change of the current state based off the input of D. So here we've changed our input to ground. We've noticed that the toggling action has stopped on our JK type flip-flop. This means that we're sending a low signal constantly in on the clock. When we flip our switch back and forth, we will see no change because the state of Q and Q0 is based off the previous state of Q and Q0 because the clock edge is always low. We'll connect back to our clock output now. We're going to walk through the other portions of the logic table talking about the preset and the clear functions for the 74 IC. Currently we have TTL switch was set back to low. We can see the low signal and we're receiving our clock as we should be. Step number one, looking at the inputs, shows that if we have a low on the preset, a high on the clear, and there is no effect based off the clock or the D input, that we are going to have a high on Q and a low on Q0. So this means that whenever we hit low on the preset and high on the clear, that we should see the red LED turn on. So remember that the preset was switch number 2, so we should flip this up, which will represent a low, and we received the red LED turning on, showing a low signal on Q0 and a high signal on Q. This was exactly what we expected from the truth table. So we'll flip this back off, and we see that the state goes back to as it was, because the TTL switch for the D input is still on low. Take a look at the next step in the logic table. Shows a high for the preset and a low for the clear. During this state, it does not matter what the inputs on the clock or the input for D is we will have a low on Q and a high on Q naught. So we will flip the switch, and we're showing still a green light. We're going to change the state of our switches here. We can see that it does not matter whether our D input is high or low, and if we change the clock to a constant low, then it still has no effect. We saw the stop happen with the toggle to show us that the clock has changed, but there's no effect on what happens there. We'll go back and demonstrate that with the preset as well. Again, the effect of the toggle switch changes nothing about the state of the IC, and the change of the clock does not have any effect on the IC. The other state of operation that's listed in the function table or the truth table for the 74 IC is when you have a low input on both the preset and the clear. This is considered an unstable operation, and what we're going to see is that we receive a constant high output on both Q and Q naught. This means that both LEDs will be turned off. In the logic of what's actually happening here, Q and Q naught are constantly going to be fighting for changing one another back to a low. The instability this creates is going to happen so fast that we're not even able to register what's happening with the oscilloscope or with the lights. So we're going to flip both to on, and what we should see is that neither of the LEDs stay on. Currently we see both of them are turned off. The state of the toggle switches and the input going into D does not matter. It does not matter what our clock looks like. We can see that the clock has been turned off. We're on a constant low. And there's been no change in state on the LEDs. What will happen is whenever we turn both of these back off, it is going to go back to whatever state would be represented based off the current state of the IC and the inputs. So when we flip these back off, we have a high on the TTL switch, and we have the clock coming in. This will give us a high on Q and a low on Q naught, which means our red LED should come on. We see that that happened. We're going to change over to the 112, take a look at the function table for it, and walk through the different pieces that we have there. We have two inputs going into the 112, whereas with the D flip-flop we only had the one. We have inputs J and inputs K that we're going to be dealing with here. We also have similar function with the preset and the clear and the clock coming in. It's important to note that we're not looking for leading edge on this one, we're looking for falling edge, and that the preset and the clear functions are going to be very similar to what we saw with the D-series flip-flop. It's important that normal state of operation for the flip-flop is with preset and clear set to high, so we can see that the dip switches are turned down, which means that we're receiving a high input for both of those. With J and K currently toggled to high, we're receiving a toggle. And if we look at the state that's expected with the truth table for the 112 IC, we see that that was the expected output, that the output going on Q and Q naught will change respectively every time that there is a falling edge on the clock input. We witnessed that a little earlier with the oscilloscope when we looked at the input going through the different probes. What we're going to do now is we're going to walk through the other states that are available with our inputs, as long as we have a high on the preset and on the clear. The first that our table lists is if we have a high on preset, high on clear, a downward edge on the clock, and low on J and K. That means that the current state of Q and the current state of Q naught will stay the same. So we see that the light to the right is on, which means that Q naught is at a low and that Q is at a high. If we go back to allow our toggle to happen and we change this whenever we have a low on Q and a high on Q naught, we should see the same result where it stays the same and does not change. So we can see that we have lows now. We have a different LED on. This is the Q output is showing low, and the Q naught is showing high, and we can see that it is not changing. So this shows that the function of the logic table is correct, that the output will be the same continuously and will not change until one of the other inputs changes. The next portion of our table shows that if we have a high on J and a low on K, that we should have a high on Q and a low on Q naught. So we saw the slight delay there waiting on the clock to hit its leading edge or the falling edge, and we saw the expected output. K is low, showing that Q naught is low. J is high, showing that Q is high. The next step of the table changes the states of J and K so that J is low and K is high, and we see an opposite output where Q would be low and Q naught would be high. So if we change the section of the switches, we should see the lights change position, which we did. The other portion of operation that we're looking for is that with a constant high on the clock, that we would see the state of Q and Q naught do exactly the same as if we had a falling edge and low on J and K, where the state of Q would always stay whatever it currently is, and that the state of Q naught would always stay whatever it was at the time of reaching a high constant on the clock edge. So we're going to take the clock, we're going to show the toggle happening to show that we do have the clock. And then we're going to plug our clock in to a constant high on the breadboard. And we see that we have no change, that the state does not change based off of the switch because we have a constant high on our clock. We'll leave both J and K set to high so that when we go back to our clock, we'll be able to see the toggling happening, showing us that our clock is active. The other portion of the logic table for the 112 IC that we're going to take a look at is we're going to take a look at the preset and the clear functions and how they operate. In the truth table, we see X's under clock J and K for any time that either the preset or the clear is low. The reason that happens is because the inputs on the clock J and K are all ignored whenever either the preset or the clear receives a low signal. So we're going to start by setting the preset, which is the switch to the right. We're going to set it to low. When this happens and the clear is on high, then Q should be high and Q naught should be low. So we see an immediate change in the outputs of Q and Q naught. Q is currently set at high, Q naught is set at low. If we turn this back off, we should go back to a toggle action. And then if we change the state of clear to so that it is low with a preset being high, we're looking for a low on Q and a high on Q naught, and we see that we have that respectively. The last portion of working with lows on the preset and the clear is reaching a point of having low on preset and clear. Similar to how the D series flip-flop worked, this is another one of those unstable operations, one that is not intended to be used. So anytime that you're dealing with this, we shouldn't have this happen because we can't really guarantee a specific outcome. Whenever we switch these to high, the note that we're given in the truth table is that this configuration is non-stable. That is, it will not persist when preset and or clear inputs return to their inactive or high levels. So we have both now set to high. We can see that we received a high on both, and we have a similar type operation happening here where there is a constant fight between Q and Q naught to take over which is high and which is low. So if we return both of these back to low, we're going to go back to whatever the current state was set on the switches, which was high on J and K, giving us the toggle, which we can see happening across the LEDs.